Hi, my name is Hannah Buckner, and welcome to Introduction to Astronomy. Today we're going to be delving into um, aspects of the Earth and how it moves, um, learning some words that may be new to some, and reviewing for others. And we'll be able to just have some fun learning more about the Earth's motion and how that is seriously a big impact on our lives and um, is such an important aspect for all of life here. So I'm excited to start this and let's begin. So as I am sharing my screen, I encourage you to um, think as we're going through this class about some things you might have questions about and start writing them down so that sorry, so that when class is over and you have my email, you'll have questions written down beforehand or during the presentation so that you can email me if I would be happy to answer any questions that you have. And so, like I said, welcome to Introduction to Astronomy. Today we'll be learning about the Earth's rotation and revolution. This coincides actually, not sponsored, but coincides with a great video from Crash Course Kids where they also talk about rotation and revolution. And so that'll actually be on the homework, which was going to be posted on the Fairbanks page, where it will really help you build your skill in applying what you've learned from this class and be able to just have confidence in knowing that what you've learned is applicable. And just to practice knowing that things that happen on Earth or that we experience as a planet are also pretty common throughout space. So I think it's really cool. And I'm not going to say too much about your homework because I think it's really interesting and I'm going to geek out about it. So I'm looking forward to hearing from you if you have any questions or if you would like to share what you've learned. I look forward to that too. So let's get started. So some important things to know. These will also be on your homework, and there'll be a little bit more explanation on that packet about what you'll be doing with these, but these are going to be terms that we'll be using throughout this class. And so I think they are pretty important to know. On the left, I've listed the terms. They are orbit, revolution, rotation, tilt, and axis. And then on the right hand of the slide, you'll see their definitions. I'm not going to go into detail about what they are right now, except for that tilt doesn't really have much of an explanation to it. Tilt means that with the axis, if my body is a planet, and I have my axis, which is right smack down the middle, and I'm tilted, you'll see that my body is tilted away from the axis, so there's a degree of change or a tilt or slant from the original position. And that's all that a tilt is. The Earth experiences it, but we'll talk about it in just a second. So I encourage you to pause this slide or pause the video if you would like, and just take time to write them down, get them into your head, and just know that these are something that it may not be something that you keep using in life, but it is something good to know. So the big question, if the sun rises every day and sets every night, where does it go when we can't see it? This was a question that many people grappled with or struggled with way back when. And I'm talking very, very long time ago, from very ancient civilizations up through probably a few thousand years ago. Not even. This was something that was even thought of through the 1600s. So at that time in history, there wasn't much knowledge about astronomy and what was out there beyond the stars. They didn't know that the Earth was at the center of the universe, which makes sense because as we look around at our planet, I'm looking around my room and my stuff hopefully isn't falling over. And it feels like, we can get up, we can walk around, we can move. It doesn't feel like we're being pushed like we would be in a car that's moving or spinning. And so it made sense to look up at the sky and say, oh, the stars are moving, the sun is moving. So that must mean that the Earth is stationary or still, and the rest of the world is moving. So the sun must be moving. But that isn't necessarily the case. They didn't really know where the sun went. All they just knew is that when the sun was in the sky, it was light, and then when the sun was gone, it was dark. And so there was a question of where did the sun go? Is it just that it blinked off and then something else happened, or was it just moving on its own? So what did that mean? And let me just, I'm going to do a new share, and we're going to go to Stellarium. And so this is also going to be on your homework. This is something that's pretty useful. So this is what I'm seeing right now. It is 4/13/2020 at 9:17. And so this is the sky. And I'm just going to turn off the atmosphere. So actually, no, I'll keep it on. As I'm going to move forward through time. And so we're going to see that as I move forward through the night, the sky keeps moving. And there's the Milky Way. Oh, and it's pretty dark. And oh, there's the sun. Wow. Okay, so the sun came back. Thankfully, we love the sun. We love the warmth, though lately we've had a lot of rain. And so where did the sun go? So when we are looking at that, what that tells us is that the sun isn't actually moving. It's us. The Earth is rotating or turning on its axis. The axis is this imaginary line that usually separating a body that is it's symmetrically or evenly breaking apart a body in half. So, like I said, if I'm talking about my axis, so I'm not falling over, I'm balanced. My axis would be from the top of my head, just cutting right down through my body, and then, I'd have one leg per half of my body. The Earth has the same thing. You'll see that there's this line here. It's red. It's called the axis. Well, the rotation axis. But it's not straight up and down between the North and South Pole. What? What does that mean? What is that? Well, the Earth is tilted on its axis. So the axis between the North Pole and the way that the Earth is looking towards the sky, it's got about a 23.4 degree difference from 90 degrees, which means it's straight up and down. And as the Earth is spinning on its axis, we see a change. We get to experience night and day, dusk and dawn, and we get to see the stars moving. And what's actually pretty cool is that we'll see this too. You'll see it with Stellarium. And if you ever come to the museum, once we're allowed to have people back, when you are looking at the North Star or Polaris, it looks like the night sky is actually moving around Polaris, and that's because the axis is actually looking at Polaris for now. In about maybe 13,000 years or 26,000 years, I'm not really sure where we are with that, but there's this thing called precession, and the Earth will eventually no longer be pointing at the North Star, so it'll no longer be the North Star. I mean, it'll still be in the north, but it won't be the North Star. And it'll probably be pointing at Vega, which is another cool star, but that's beyond the point. So the Earth is spinning on its axis, which is pointing towards Polaris. And the Earth is actually spinning at about 1,000 miles per hour, which is really cool. And this is an interesting way to actually see it. I'm just going to close this. So we just start. This is called Solar System Scope. This will also be something really interesting to use. You don't have to use it for your homework, but I just put it on the document so that you can see it and use it when you would like. You get to explore the solar system. And this will be something that's used in some other classes of mine that I'll be teaching. And so it's cool. So there's the Earth. We're going to go down and visit it. So this is what I was talking about in terms of the tilt. So let's see. Okay. So here is Europe and the African continent. And then here is Vermont, which is where we are. And you'll see that we have reached nighttime. And so if we are to play it, this shows spinning at 30 minutes per second. And so now we here are about 2 a.m. And we can see right here is when this part of the world is experiencing day to night. And then if we're to go over here, this is all daytime. And this is day to night. So we're over here is experiencing morning. And so the Earth is spinning on its axis. Let's see if we can see it spinning. No. Anyway, it's cool to play around with, definitely useful. But the Earth spins on its axis, and that's how we experience day and night. So that is pretty cool. Was I not? I feel like I was not actually showing you this, and that's really upsetting. Let's see. So if I wasn't actually showing the video, I just realized that. This is what the spinning looks like. So as I was saying before, this is the day to night, I mean night to day, and so going to morning, and then nighttime through dusk into the evening. And so you get to see the Earth spinning, and it's tilted at this point towards the sun. So the northern hemisphere is tilted towards the sun. It's beautiful. So I hope that we'll be able to use this. Going back to the PowerPoint. So as I said, the tilt is about 23.4 degrees. This varies over time. So because the tilt of Earth causes seasons, it depends on which part of the Earth is receiving more direct sunlight. That'll be talked about in another class probably. But because of the tilt, it can vary between about 24, 25 degrees and 21 degrees. So the bigger the tilt means the closer the top hemisphere is getting to the sun. And then the lower, the closer it is to being 90 degrees up. And so the smaller that the tilt is, it means that the more likely the planet will experiencing about one season. So the seasons are quite similar. But when it's closer to the sun, you know, the tilt is closer to the sun, the seasons are more exaggerated or very different. So you could experience very cold winters versus a very hot summer. But that's given that global warming doesn't come into effect with that. But just from the tilt aspect, tilt can determine what the weather can be like, it can also impact what the sun's path is going to be like in the sky. So the tilt and the rotation are quite important. Okay, so the Earth isn't just spinning on its axis. It's actually also revolving or orbiting around the sun at the same time. So that means as the Earth is spinning around its axis, it's also spinning around and around and around and around and around and around and around. And it is always doing this, but we can categorize it in terms of understanding time. So we actually get our definition of a year from our orbit. And orbiting is very important because one full orbit is one revolution. And sometimes you can hear about revs per minute or revs per second. That means how many revolutions per minute or second. You usually hear about that with bikes, or I guess sometimes with cars too. So one revolution for us is 1 year. So one revolution per year is 365 days. And so that can just be anywhere on here, whichever way you choose to look at a year. So for me, I measure my revolutions around the sun, or my orbits around the sun, on my birthday, which is Halloween. And so I've done 22 revolutions and about a half. So I've done 22 and a half revolutions around the sun, and I've got 6 more months to go before I've done 23. Another cool thing about the Earth's orbit is that so as astronomers, we also look at eccentricity of an orbit, which essentially is telling us that the orbit of something can be either like a circle, or it can be slightly less circular, less of a circle, more of an egg, or very ovular. And it's actually pretty cool. And you can also discover that on this. Wait, let me use this. You can also discover that with solar system scope. So if you back out and you go to the solar system, you can see how Mercury has a slightly ovular orbit, but not that much. They don't really show it very well here, but Earth does have an ovular shape. But they do show it with, this is Eris. Eris is a exoplanet. It's a dwarf planet that we just talked about in another class. And so this is also pretty cool, where you can, if you go to Earth and we hit play, you'll see that as the Earth is orbiting, it's also rotating. And so we can speed this up, doing hours. And so it's going to get kind of wonky. And so we can see that as time is passing, the Earth isn't just rotating on its axis, it's also orbiting around the sun. And so all of the planets do this. Sometimes they're slower, sometimes they're faster. Some of them don't actually orbit. And I'm not sure if Mercury does that or not, but it's something that you can definitely figure out on your own while you play around with this. And I definitely recommend that you do that. Look at Sirius, it's going really fast. It's definitely a cool tool to kind of mess around with the solar system in a safe way. And it definitely can illustrate to you in a clear way if you don't have a globe and a lamp, because that's also a great way to kind of show how revolutions and rotations can work. I would show you, but I don't have a globe myself. But it's a cool tool to be able to use that. And so you can really see that the Earth is the one that is creating all of this change in our sky, because we're the ones who are moving at such a speed that it's quite noticeable. And I thought you'd also be interested to know that the Earth is orbiting at an average speed, meaning the speed changes throughout the year. So at this point where the Earth is closest to the sun, it's actually moving quite fast due to gravity. And then at this other end, it's moving slower. So that's the fastest and slowest that the Earth will ever be. So the mathematical difference of the two is the average. And so the speed or the velocity that the Earth goes on average is about 107,218 kilometers per hour. For those of you who are not familiar with kilometers, in America we tend to use miles per hour. That is about 66,622 and 0.17 miles per hour, which is very fast. If you tried to go that fast on Earth, I think you would pretty much get a speeding ticket by every officer. You'd also go very fast around the world. I think it's also faster than Earth's escape velocity, which means you need to go a certain speed in order to escape Earth's gravity, so you can get out into space and move on your own, which is really cool. So in general, what looks like to us the motion of the sun in the sky is really just an effect of the motion of the Earth. And so when we are seeing the change from day to night or night to day, and the sun is missing and the stars are moving, it's not necessarily that the stars themselves are moving. They are, but they're so far away that we can't really notice. And the sun, it moves, but very, very little amounts. Not in the way that it compares to the rest of the planets. And so the changes that we're seeing are because of the Earth's rotation on its axis. And as it moves through through the solar system throughout the year, it can also impact what stars we see and what planets we see. And so with that, I will leave you. Again, if you have any questions, please feel free to email me at hbuckner@fairbanksmuseum.org. I would be happy to receive questions about the class, questions about the homework, or if you feel like you want to send me your homework, I'll be happy to look at it. And yeah, thank you so much for having an interest in astronomy. It is my absolute joy and pleasure to share the love and joy of the cosmos with you, and I will see you next week. Thank you so much, and have a wonderful day.